Hi, I'm Chris Thompson presenting with Dwayne Michael, and our tool is called SharpSCCM. Today we're going to talk about using SharpSCCM to coerce NTLM authentication from servers and clients, gather credentials, and move laterally in SCCM environments. We're also going to provide guidance on how to prevent and detect the techniques implemented by SharpSCCM. Here's a link to SharpSCCM's GitHub page where you can clone the tool, as well as some links to our research on new SCCM attack primitives that go into a little bit more detail than our talk does today. Also, please hit us up on Twitter if you'd like to chat about SCCM research or development. I want to give a quick shout out to the authors of Power SCCM, Matt Nelson, Will Schroeder, Jared Atkinson, and Matt Graber for laying the groundwork for SharpSCCM, as well as Evan McBroom, Elad Shamir, and Nick Powers for helping us out with our research. On the agenda for this talk, we're going to go through a quick SCCM crash course, familiarize everyone with the terminology involved in the attacks we're going to demo, and then we're going to dive into 3 demos for you. The first demo, we're going to show you how to use SharpSCCM to coerce NTLM authentication from SCCM servers by abusing automatic client push installation. In the second demo, we're going to show you how to use SharpSCCM for lateral movement after taking over an SCCM server. In the third demo, we'll show you how to dump domain credentials from SCCM clients. After the demos, we're going to explain how each of these attacks can be prevented or detected, and we'll provide some resources for testing SharpSCCM in a lab environment. So we're going to do a quick crash course in SCCM. The systems in an SCCM environment are called a site. Every site is identified by a 3-character site code, for example PS1, but it can be set to anything. And all of the servers in a site that serve an SCCM role are called site servers. One of those roles, and the one that SharpSCCM interacts with primarily, is called a management point. So how does a site know what computers are in the SCCM environment? There are a couple different methods. It can query Active Directory for new systems. It can conduct periodic network discovery scans. But the only one that's enabled by default, and the one that we're going to abuse to coerce NTLM authentication, is called heartbeat discovery. So that's when a computer that is a client of SCCM site notifies its management point that it exists every so often with a heartbeat message. By default, that message is sent every 7 days. Boundary groups in SCCM are just IP address ranges and Active Directory domains that are defined to provide a scope for other actions, like automatic site assignment, which is when new computers that are discovered in one of those IP address ranges or AD domains are automatically assigned to a certain SCCM site. Alright, so how does the SCCM client software actually get deployed to computers in a site? So there's quite a few methods, but the one that SharpSCCM abuses is called client push installation, which is when the server connects to a machine's admin share, copies over the files needed for installation, and then executes the installer. So an SCCM administrator can either kick client push installation off manually through the console, or configure the site to automatically push the software out to new systems that it discovers within a boundary group, like a subnet, or new systems in an AD domain. The admin can either configure client push installation accounts that the server is going to use when it tries to install the client on the system, or if no accounts are specifically configured, then the site server is going to attempt to authenticate to that system with its machine account. In environments where client push installation is used, whatever accounts are used for that client push installation are required to have local admin privileges in order to actually install the SCCM client successfully on those remote machines. So basically, if we can get the site server to try and push the client software to a system that we control, we can capture and crack or relay the creds for the stored installation accounts, which are required to have local administrator privileges, or relay the server's machine account. So how do we make SCCM think that the client needs to be installed somewhere that we control? So back in 2018, Matt Nelson discovered that when automatic client push is enabled for a site, if you're elevated on a system and uninstall the SCCM client software on that system, the server will try to authenticate to that system using NTLM to reinstall the client software, and that you can capture creds that way. However, when I tried to do this, I found that by default it can take up to 3 weeks for the server to reattempt installation of the client after detecting that the client is no longer installed. So pretty soon after Matt discovered this, Microsoft released a version of SCCM that allowed Kerberos auth to be used for client push, but the option to allow NTLM is still enabled by default. So after seeing Matt Nelson's tweet and familiarizing myself with client push installation a bit, I wanted to see if a tool could be built to demonstrate the risk of these attacks. On kind of my wish list for this particular abuse, I wanted to cause near instantaneous NTLM authentication from the server. I wanted to be able to send that authentication to an arbitrary system, and I didn't want to have to be local admin on the system that I was requesting that authentication from. So how can we do that? Well, there's a concept in SCCM called a client registration request, where any system can send a message to a management point saying, I'd like to be added as a device in the SCCM database, and the SCCM server will gladly oblige. A management point will accept these new device registration requests when they're signed and encrypted using a self-signed certificate that we can create ourselves. There's also a concept of heartbeat data discovery records, or DDRs, which are those periodic messages we talked about, where clients send a management point updates to their hardware inventory and things like whether the client software is installed and functioning properly. So what if we create a client registration request for a fake system and then send a DDR to the management point saying that the client is not installed on our fake system? We found out that when certain properties are sent in that hardware inventory in the DDR, the server will immediately attempt to install the client on that specified system. Specifically, when automatic push is enabled and the DDR says that the client software isn't installed on a system running Windows, the server is going to immediately authenticate to that system to try and install the client software. Unless PKI certs are required for client authentication in the SCCM environment, the server won't verify that the DDR came from a legitimate existing client, and it won't validate that the system noted in the DDR is actually at the IP address that the DDR originated from. So the result is we can specify any NetBIOS name, FQDN, or IP address in that DDR, and the site server will try to install the client on it. After trying to figure out all the ways that this might be prevented, I figured out that the management point will still accept client registration requests and heartbeat DDRs and kick off that client push installation when no discovery methods are enabled, when manual approval is required for new devices, and when enhanced HTTP communication security is enabled. So how does SharpSCCM actually do this? First, it creates a self-signed certificate on the machine it's run on. Then it creates a registration request for that arbitrary name. That's going to be the name of our new fake device. The management point will create a device record in the database for that device, and then we can create a DDR and an inventory on our fake client, send a heartbeat DDR for that fake client name, and the management point will assign that device to a site based on its boundary group. Then it will initiate client push installation if those prerequisites we talked about were met before, and that will cause the site server to connect to the admin share on our specified machine, where we can capture or relay those credentials. So an attacker only needs access to a Windows SCCM client as any user to execute this attack using SharpSCCM. You don't need local administrator privileges. However, if you want to run capture and relay on the same server that's used, on the same client that's used to execute SharpSCCM, you do need local admin privs in order to take control of port 445, where that connection to the admin share will come in. If you have access to a separate capture and relay server, you don't need local admin privileges at all. All conditions for successful NTLM relay apply here as well. If you're relaying creds to SMB, SMB signing must be disabled on the target. If you're relaying to LDAP or LDAP-S, either signing or channel binding must be not required on the server. So here's what the attack looks like. We're going to be focusing on the box on the right. Our compromised SCCM client, where we're going to be running SharpSCCM, is going to create that registration request for an arbitrary name to the management point, then send a heartbeat DDR for that name that has our inventory saying that the client is not installed on that machine, and then the management point is going to try to connect to that machine, and that will cause the NTLM authentication that we can then relay to the service and target of our choosing. All right, we're going to do a quick demo of SharpSCCM's invoke client push function. In our demo lab, we have an SCCM management point, Atlas, We have an SCCM client, Cave Johnson PC. We have a domain controller, GLaDOS, and we have a capture and relay server for NTLM running Kali Linux. All right, now we're going to take a look at our management point, Atlas, and look at the vulnerable configuration settings under Administration, Site Configuration, Sites, Client Installation Settings, Client Push Installation. When a site is vulnerable to this attack, the Enable Automatic Site-Wide Client Push Installation option will be checked. This is not a default option and needs to be set by the site administrator for this attack to be successful. Also, the Allow Connection Fallback to NTLM setting must be enabled. This is enabled by default with SCCM and needs to be explicitly disabled in order to prevent this attack from occurring. Next, we're going to click on the Accounts tab, take a look at the client push installation accounts that are defined here. In order to install the Config Manager client software on legitimate hosts, this account needs to have local administrator privileges on that machine. The site server will attempt to connect to the admin share on the specified target and authenticate to it with NTLM credentials if the default setting is enabled and an IP address is supplied instead of the NetBIOS name. If that authentication fails, the machine account will attempt to authenticate to the admin share, which we could then relay to a domain controller in order to conduct privilege escalation attacks such as resource-based constrained delegation, shadow credentials, or ADCS attacks. Also on the management point server, we can take a look at the ccm.log and ddm.log files in the Configuration Manager Trace Log tool, cmtrace. And this is going to show us in near real time the messages that come into the management point when SharpSCCM is run. Next, we're going to go take a look at our Kali VM. Its IP address is 192.168.57.130. That is the IP address that we're going to set the NetBIOS name of our new device registered in SCCM to in order to kick off client push installation to that address. We're also going to set up NTLM Relay X and capture any NTLM version 2 hashes into this file over here on the right. Next, we're going to take a look at our Configuration Manager client, and in order to take a look at its settings, we're going to run SharpSCCM local site info. That's going to provide us with the name of the current management point for the client, Atlas, and the 3-character site code, which is PS1. Then in order to run the attack, we're going to run SharpSCCM, the name of the management point, Atlas, the site code, PS1, invoke client push, and then specify the IP address of our listening machine as the target. SharpSCCM is going to create a client configuration request to register a new device in SCCM with the NetBIOS name set to the IP address that we want NTLM creds sent to. Then it's going to send an inventory report for that new device that says that the client is not installed and for the management point to check it out. Next, we're going to head over to our management point Atlas to take a look at the trace logs between SharpSCCM and our server. And if we scroll down a bit, we can start to see messages that are related to a new machine name where the machine name is set to the IP address we specified, and then attempts to connect to the administrative share using the client installation account, and then the machine account. And we can see that those attempts failed using the client installation account and the machine account. And if we pop over to our Kali VM, we can see that those installation attempts resulted in NTLM version 2 authentication, and we can either try and crack these creds or then relay them to a host of our choice. Typically, you would relay the client installation account to a system where SMB signing is disabled, where this is likely to be a local administrator, such as another workstation, or you could relay the machine account for the site server to a domain controller to attempt to take over that machine. Next, we're going to talk about using SharpSCCM for lateral movement. So it's pretty common to see PowerShell or a C2 agent being executed on an SCCM client when you have SCCM full administrator privileges in the environment you're testing. There's a lot of tools that do this, and basically what's happening what those tools are doing are deploying a hidden application to a group of clients called a collection, and then that application executes PowerShell or a C2 agent. So in situations where maybe your PowerShell or C2 agent is being blocked, or executing that in general could result in detection, there's a third technique available to us where we can coerce NTLM authentication from either the logged in user or system. And basically, the only difference between this technique and the PowerShell or C2 agent techniques are that we set the installation path of our malicious application to a UNC path we control, forcing that client to authenticate to that arbitrary system in the UNC path. So if we look at this a bit more closely, our Windows host that we're executing from running the SCCM client, that we have full administrative privileges in our domain context or user context, first makes a request to the management point to add a device to a collection. So this is going to be the device that we want to deploy our application to, where we're going to request authentication from. So let's say our target's name is GLaDOS. We want to get authentication from whoever's logged into GLaDOS. We're going to add GLaDOS to a collection. Then we're going to create an application with an installation path of an IP address that we control. So that's going to be our capture or relay server. We're going to create a deployment to tell that collection of devices to install our application from that UNC path, and we're going to tell that collection to immediately request application updates. Then the management point is going to notify that target machine GLaDOS of the new deployment that's available, and the target machine GLaDOS is going to connect to our capture and relay server, which can then relay those creds to another target. All right, we're going to do a quick demo of SharpSCCM's exec function, which can be used for lateral movement, either by executing a payload from a specified UNC path or by coercing NTLM authentication from an SCCM client. You can either execute these actions in the context of the logged in user on a machine or as system, and this function requires full administrator or application administrator privileges to run in SCCM. Our lab setup's pretty simple in this one. Atlas is our SCCM management point, Cave Johnson PC is our SCCM client, GLaDOS is our domain controller, and Kali Linux is our capture and relay server. Alright, so how do we actually find out where users are logged in so that we can coerce authentication from them? So SharpSCCM has a couple of methods that can help with this. The first function is the getDevice function. So if we specify Atlas as our management point, PS1 is our site code, and run getDevice, we can specify a user administrator, and this is saying, please tell me all the devices where administrator was the last user to log on. So if we execute that, we can see that the last logon username on the system GLaDOS was administrator. However, there are some caveats to this approach. This last logon username field is populated approximately every 7 days by SCCM clients by default, so can't really be relied upon, could be stale. Same thing with last logon timestamp. This is grabbed from Active Directory, and this can take 7 to 14 days to fully replicate. So another option available to us is the getPrimaryUser command. And with this function, we can say, please tell me the primary user for a specific device. So in this case, GLaDOS. This one is a little bit more reliable. The username that is associated with GLaDOS is administrator here, and this one is populated by SCCM based on the amount of time that a user spends logged on to a system. They're automatically created a relationship between those two objects. So there's two ways to find users using SharpSCCM. Now we're going to go over to our Kali VM, where the IP address is 192.168.57.130. That is going to be our relay server, and we have NTLM Relay X running down here on that interface to capture and display hashes in this window on the right. Alright, now that we know that administrators logged into GLaDOS, we want to request authentication from that account. So we're going to use SharpSCCM's exec function to do that. We're going to type SharpSCCM the name of our management point atlas, the site code PS1, exec. We're going to specify GLaDOS as the device that we want to request authentication from, and we're going to specify our relay server's IP address with the R option. The first thing that SharpSCCM is going to do is create a device collection. Next, it's going to add our target GLaDOS to that device collection, and then it's going to wait for about 15 seconds for that collection to populate on the server side before continuing. In a real-world SCCM environment, this number probably needs to be set a little bit higher, and we plan to add some functionality in the future to create timing profiles for that waiting period if it needs to be a little slower for a larger environment. In the meantime, this value can be changed using Visual Studio in the management point WMI file. Next, SharpSCCM is going to double check that our new collection contains our target GLaDOS. Then it's going to create a new application. It's going to hide that application from the Configuration Manager console so that admins can't see it when they log in. And it's going to execute in the context of the logged in user that we know is administrator. SharpSCCM's exec function also has a TAC-S option to execute in the context of system, which you might want to use to execute code, or if web client is enabled on the system, you can request NTLM authentication from that system over HTTP by specifying IP address at port. Next, SharpSCCM is going to deploy our application to our device collection that includes GLaDOS, and it's going to wait for that deployment to become available before forcing every member of that device collection to check for updates and execute any new applications. And then it's going to wait for about 1 minute for that NTLM authentication to roll into our Kali VM before cleaning up and deleting our deployment, our application, and our collection. If we go back in time a few seconds while SharpSCCM is waiting for that 1 minute time period to our Kali box, then we should see the administrator NTLM version 2 hash come in. Alright, now we're going to use SharpSCCM exec to execute a binary from a specified UNC path. So we're going to use SharpSCCM, the name of our management point atlas, PS1 the site code, exec. We're going to execute code on GLaDOS, and we're going to specify our path with the TAC-P option to atlas/sources/calc.exe, where we staged a copy of calc, and we're going to run with the TAC-S option to execute as system. Alright, if we skip ahead to the part where SharpSCCM is waiting for authentication and then head over to our target GLaDOS, we should see calc in just a few seconds once the deployment has reached our target. There it is, and if we check it out, it's running as system. So how do we prevent these NTLM relay primitives from being used in our environments? For the client push installation technique, you can simply disable the allow connection fallback to NTLM option in your client push installation properties. This is the only thing that you need to do to prevent the client push installation attack from occurring. You can optionally use software update based client installation and completely disable automatic site-wide client push installation. The two accomplish the same objectives, and software update based client installation is much more secure in comparison. You can also require SMB signing on endpoints to prevent the relayed credentials from being used. Same thing with LDAP and LDAP channel binding and signing being required on systems like domain controllers to prevent privilege escalation attacks from occurring with the relayed machine account credentials from a site server. Detecting client push installation abuse is a bit trickier because SCCM's logs aren't really meant to be ingested into a SIM. They're more for troubleshooting issues with client policies and things like that. However, here are some potential indicators of compromise that could be used to create detections in your environment. So the only way that we're aware of to completely mitigate the lateral movement techniques discussed here is to disable outgoing NTLM traffic on every SCCM client or for the domain, which obviously is very challenging. However, detecting these techniques can be implemented using the same GPOs that would completely disable NTM, but by setting them into audit mode, you can start to identify clients that are using NTLM for legitimate purposes and add them to an exclusion list in the policy that will eventually deny all outbound NTLM. Also, you can enable audit policies for inbound NTLM connections to systems that are susceptible to NTLM relaying, such as those where SMB signing is not required, and it can't be, or LDAP signing or channel binding is not required to reduce the effectiveness and detect those relays.
Another attack vector provided by a SharpSCCM is credential gathering. Specifically, we can use SharpSCCM to retrieve, decrypt, and dump network access accounts. Network access accounts are Active Directory accounts that are used by systems that may not yet be joined to an Active Directory domain, so the client may authenticate to the SCCM distribution point to retrieve software. This account gets pushed to every SCCM client via a machine policy. Once the host receives that policy, the credentials are stored locally as DPAPI blobs protected by the system's DPAPI master key. The blobs are retrievable via WMI as a privileged user. The system master key is encrypted with a password derived from the DPAPI system LSA secret, which requires elevation to system to retrieve. However, this is arbitrary since we must be privileged to retrieve the blob via WMI anyway. The blobs themselves live in the SIM repository as hex strings, and due to some issues with SIM internals and how SIM and WMI clean up that database, the blobs may persist after the SCCM client is uninstalled from the host, or after account rotation. For example, if account A was configured as the network access account, and then the organization changed it to account B, account A's credentials may persist on the host indefinitely. The machine policy containing the obfuscated credentials can also be requested from the server and deobfuscated before the client protects it with DPAPI. Our coworker Evan McBroom POC'd this in C, and Adam Chester recently POC'd this in Python and C with a great walkthrough published to his blog. Now we'll get started with the demo about network access accounts. For starters, we'll demonstrate how to configure or unconfigure a network access account. So on our SCCM server, we'll first navigate to the SCCM console. Here you see the default view of what you would see when you first log in. And then we'll go to Administration, and then Site Configuration, Sites, and then we'll choose the site of interest, in this case, PS1. Right-click, go to Configure Site Components, and Software Distribution. In the dialog that pops up, we will see a Network Access Account tab. And here you can see that there's an option to specify the account that accesses network locations. This is the Network Access Account. Here you can see that we have one configured, and we can add an additional one based on an existing Active Directory account or one that we've already configured, or we can remove it. Now that we've demonstrated how to configure and unconfigure the network access account on the SCCM server, we'll move over to the SCCM client. First, we'll demonstrate that we're in a high integrity process, and then we will query the network access account blobs via WMI in PowerShell. Here you can see that we have received two hex strings, which are DPAPI protected blobs, one for the network access username and network access password. Now, if we retrieve the master key, we can decrypt these blobs. So in order to retrieve the system DPAPI master key, we can use SharpSCCM, which has DPAPI functionality heavily derived from Will Schroeder's Sharp DPAPI project. So in order to do this, we'll use SharpSCCM's local NAA WMI command, which will execute a WMI query similar to the one above. And then it will elevate the system in order to retrieve the LSA secret that is used to encrypt the DP-API master key. And then we list out the system master keys here. And then we decrypt the DP-API protected blobs. And so here at the bottom, you can see that we have the plain text network access account username and password. As previously mentioned, you can also retrieve DP-API blobs for the network access account from the SIM repository, which is just a file on disk. It's a binary file. Here's what the SIM repository looks like, open in a text editor. So as I said, it's a binary file, so it looks a little crazy. However, we can see that we can read these DP-API hex strings. So here we can see CCM network access account. So this could potentially be either the username or the password. However, there are multiple instances, and so if we just iterate over all of them, we can potentially find multiple accounts. And so as I mentioned, if you uninstall the SCCM client, these blobs will remain. If you rotate the network access account, the blobs for the old account will remain. So if we take one of those blobs and do a little cleanup on it, so here we take that hex string, which is cleaned up, remove all the white space, and store it in this string variable. And then here we parse it into bytes, store it in the bytes variable, and then we convert it into a base 64 string. Then using SharpDP-API, we can use the blob command, target our base 64 string, and then specify the master keys, which is masterkeys.txt, which contains this master key cache that you see here. We can successfully decrypt and see that we have the network access account username. You would just rinse and repeat this for the password or any additional blobs that you may find. Unfortunately, at the time of recording, as you see, we don't have this built into SharpSCCM yet. It's something that we're working on, but we just wanted to demonstrate the capability by doing it manually and using SharpDP-API. So keep an eye out. Hopefully this feature will be finished soon. Unfortunately, there isn't much you can do about network access account abuse like this. Microsoft actually recommends not using network access accounts anymore and using enhanced HTTP instead. However, even if you do move to enhanced HTTP and you stop using the network access account, you should disable the network access account in Active Directory because those blobs are still on disk. And so an adversary could still retrieve them and use that account. So if the account, even if it's no longer configured as a network access account, but still an active AD account, it could still be abused. So what's next for the SharpSCCM project and our SCCM research in general? We have a ton of ideas and we're constantly working on them. However, a few of the priorities are grabbing the network access account from the policy as POC'd by Evan and Adam. So it's already been POC'd, but we just haven't worked it into the tool. So we're hoping to prioritize that in the near future. We'd also like the option to save the self-signed certificate that's used to communicate with the management point in the user certificate store so that we can reuse it. And then we'd also like to use PKI certificates when required by the site and the user executing SharpSCCM has local admin privileges. Again, we have tons of ideas, and if you have other ideas and you'd like to work with us, please let us know. We're always looking for collaboration. You may be thinking, I want to get involved. I have ideas, but building an SCCM lab sounds like a nightmare. And you are absolutely correct. Luckily, Microsoft just recently released this Windows and Office 365 deployment lab kit. It's a fully operational SCCM lab. It's already built for Hyper-V, so if you're on Windows, you can use this option. Including download time, it takes about 2 hours to set up. Has evaluation licenses good for 180 days. You can see the link to the reference here on the slide. And if you want more resources on building a lab, visit Chris's blog post on the SpectraOps blog. That concludes our presentation on SharpSCCM. We hope you enjoyed it, and we hope you'll join us on researching further SCCM attack primitives, as we think there's a lot to be discovered here. Again, here's a link to the tool on GitHub and some links to our research on the SpectreOps blog. Again, we are Dwayne Michael and Chris Thompson from SpectreOps. You can reach out to us at Mayhem and Subatomic on Twitter and the Bloodhound Slack.